Good morning or good afternoon, fifth graders. This is Miss Lewis coming at you live with a video about states of matter. So we're going to be talking through our note page today. If you don't already have this out, you need to get this paper on your desk and get a pencil ready. So pause the video now if you need to go get this paper. Otherwise, go ahead and keep watching. All right, if you notice, this is a 3-circle Venn diagram. We have 1, 2, 3 circles, and they're actually interlapping or overlapping in multiple ways. So we're gonna start with talking about liquids here on the left side. So you're gonna notice we have liquids, okay? And we're gonna be talking about their general properties. So liquids, we know this, actually their shape changes to fit their container. Okay, so we're gonna write that in. Their shape changes to fit their or its container. Okay, so if you can write that down in your notes, go ahead and take a look at this liquid, right? We usually use water as an example because it's easy to understand how it the 3 different forms. And so we have the water in this glass that is taking the shape of the glass, right? If I pour this water onto the desk, it's gonna actually take the shape of the desk. I'll do a little bit, see if you can see. It's actually gonna lay flat and take the shape of the desk. You can kind of see that. If I were to pour this water into a different container, it would take the shape of that container. So that's a major property of liquids. Okay, let's talk about solids. We know solids actually have a definite shape, so we're gonna write that down. We have solids over here. Have a definite shape. And that means that their shape can be altered and changed, but it's not altered all the time, okay? So they have a shape, and it usually stays that way unless it is altered on purpose. So if we think about the cup that this water is in, the cup is a solid and it has a shape already. It's actually given the shape to the liquid. Okay, let's talk about gases. Okay, gases. And these are the 3 main states of matter. There's also a state of matter called plasmas. I want you to go ahead and write off to the side. We're not going to talk too much about plasmas today. So we're going to just focus on the 3 states of matter, solids, liquids, and gases. But do know that there is another natural form or state of matter called plasmas. So with a gas, we know that gas is actually something that does not have a definite shape or volume. So there's actually water molecules in the air right now that we'll talk about in just a second that don't have a definite shape or definite volume. So we're going to write no definite or defined. Do you see that root? Define. No definite shape. Oops. Or volume. Now, there are some similarities between these different states of matter. Let's talk about the similarities first between solids and gases. I want you to think for a second, what do you know about solids and gases? So solids, let's look at some solids. Actually, I forgot to show you my ice cubes here, right? I have some ice cubes that are actually already doing a couple things that are going to help us. So first of all, they're melting a little bit because I got these set out before I started this, and now they're melting a little bit. So they are turning from a solid into a liquid, okay? What I want you to also notice on this cup is that you can see there is some condensation forming. Do you see that when I wipe, right? This condensation, the water's not seeping through the glass, but what's happening is the water molecules in the air are coming in contact with this cold surface and they are condensing. That's why it's called condensation. They are condensing back into a liquid state. So both solids, like the ice cube, and gases, like the water vapor in the air, can turn into liquids, can become liquids. So we're gonna add that in here, and I'm gonna do that with a black. Now you can just use a pencil for all of this, or you're welcome to color code. So we're gonna say can become liquids. And I'll post a picture of this final three-circle Venn diagram for you to see, okay? We don't often, let's see. All right, let's move along. So we have liquids and solids have some things in common. Liquids and solids. Now, can become liquids. Let's go back to that for just a second. Some of you in your Scientists of the Week were experimenting with dry ice. Now, some of you watching this video are going to remember this word that we talked about, but what was the special property that carbon dioxide is doing in dry ice? It's a solid, right? And then what's it doing? It's not actually going into a liquid state. It's going directly into a gaseous state. And that process was called sublimation. If you remember that, give yourself a pat on the back right now, even at home, okay? So that was actually a unique property of carbon dioxide that we were studying with our dry ice experiments. Okay, let's go over here to our similarities between liquids and solids, okay? So liquids and solids, they both have a definite volume. And I'm gonna squeeze this in here. I'll get close so you can see this at the end. Have a definite volume, meaning they take up the space, okay? They both have a volume. This water is taking up the space of the glass. This cup has a volume. It is made up of molecules. When we think about the solids around our house, the lamp, for example, or a banana, or a book, it has a volume, right? It's made up of molecules, okay? Anything that is a 3D shape. So what we're gonna do is we're going to also look at a second similarity between these two states, liquids and solids, and talk about how they both have tightly packed molecules. Tightly packed molecules. Now remember when we were reading Made of Matter and we were talking about atoms and how atoms are like the building blocks of all matter. If we broke everything down to its smallest unit, it's called an atom. And then when a couple of atoms, or when several atoms join together, they're called molecules. When we zoom in and look at the molecules in liquids and solids, we see that they're actually pretty tightly packed. And we're going to draw some pictures of that in our next note page, so stay tuned. When we actually look at the molecules of a gas, they're much more spread out. So just be thinking about that. This is something that these two states have in common that is very different than the gas state. Okay, and then the last thing we're going to do is we're going to look at what all three of these states of matter have in common in this little section right here, and we're going to fill that in. So all three of these are obviously states of matter, so we can start with that. And all three of these can change from one form to another. Can change, I'm going to shorten this, one form to another. And again, I will post this so you can read it nice and clearly, okay? But go ahead and make sure you filled in all these notes and then stay tuned for what we're going to be doing next.